We all know what concrete is, but did you know that concrete is the world's second most consumed material after water? On an average, every year, 3 tons of concrete are used for every person in the world. For reinforcement and shrinkage control, concrete requires steel, and we produce a lot of steel. In 2019, 1.87 billion tons of steel was produced, enough to build an Eiffel Tower every 3 minutes, or 180,000 Eiffel Towers in a year. 10 times more steel is produced now than it was in 1950. When 1 ton of steel is produced, 1.83 tons of CO2 is released into the atmosphere. So, what does all that mean? It simply means that our need for steel is increasing. More steel production means more mining, more CO2 emission, and increase in greenhouse gases that cause global warming. There are several environmental impacts of using steel in concrete, and that's not all. Steel can create durability issues, limiting concrete's life. Corrosion is one of those issues. Transporting, storing, and laying steel is also labor, time, and money intensive. The end-of-life recycling of steel-reinforced concrete is both difficult and expensive. The list is long. Now that we know the problem, let's talk about the solution. 52% of all the steel produced is used in building and infrastructure, which means that there is a huge opportunity for this industry to reduce their carbon emissions by promoting the use of sustainable alternatives. While steel is integral to large structures, light infrastructure such as pathways, roads, and walkways make up to 30% of all concrete and can use steel alternatives that are durable as well as sustainable. Synthetic fibres are an alternative for such applications. At FibreCon, in partnership with James Cook University, after a full-scale research and testing program, we developed a new 100% recycled synthetic fibre, eMesh. eMesh represents the next generation of innovation in fibres in concrete, which is more sustainable, cost-effective, faster and safer to use, and it's an Australian innovation. eMesh is used by local councils, government infrastructure developers, architects, landscape architects, and mining companies for a range of applications based on third-party audited environmental product declaration. eMesh fibres are ideal for footpaths, bikeways, small precasts, and pavements. eMesh is ideal for aggressive marine environments. It eliminates corrosion issues in both highly acidic and alkaline environments. Use of eMesh in precast also leads to faster production and cost reduction. eMesh is a winner of the Australian Innovation Challenge Award 2015. eMesh has several approvals, accreditations, and registrations. By reducing use of steel, eMesh can save up to 90% of CO2 as compared to the steel mesh. It can also reduce up to 90% of water consumption. eMesh helps in many ways. So far, eMesh has used 250 tons of recycled plastic, resulted in reduction of over 5,500 tons of carbon dioxide emissions, saved over 100,000 cubic meters of water, saved 1,100 tons of fossil fuels, and also provided 11,000 hours of employment to NDIS workers. To reduce the carbon emissions sustainably, we require big change to our conventional approach. And when a big change is required, every small step counts.